So let's ask ourselves some interesting questions about alphabets in the English language. And in case you don't remember or are not in the mood to count, there are 26 alphabets. So if you go A, B, C, D, E, F, G, H, I, J, K, L, M, N, P, Q, R, S, T, U, V, W, X, Y, and Z, you get 26. 26 alphabets. Now let's ask some interesting questions. So given that there are 26 alphabets in the English language, how many possible three-letter words are there? And we're not going to be thinking about phonetics or how hard it is to pronounce it. So for example, the word zigit would be a legitimate word in this example. Or the word skudge would be a legitimate word in this example. So how many possible three-letter words are there in the English language? I encourage you to pause the video and try to think about it. All right, I assume you've had a go at it. So let's just think about it. For three-letter words, there's 3 spaces. So how many possibilities are there for the first one? Well, there's 26 possible letters for the first one. Anything from A to Z would be completely fine. Now, how many possibilities for the second one? And I intentionally asked this to you to be a distractor, because you might be, we've seen a lot of examples where we're saying, oh, there's 26 possibilities for the first one, and then maybe there's 25 for the second one, and then 24 for the third. But that's not the case right over here, because we can repeat letters. I didn't say that all the letters had to be different. So for example, the word would also be a legitimate word in our example right over here. So we have 26 possibilities for the second letter, and we have 26 possibilities for the third letter. So we're going to have, and I don't know what this is, 26 to the third power possibilities, or 26 times 26 times 26. And you could figure out what that is. That is how many possible three-letter words we can have for the English language if we didn't care about how pronounceable they are, if they meant anything, and if we repeated letters. Now let's ask a different question. What if we said, how many possible three-letter words are there if we want all different letters? So we want all different letters. So these all have to be different letters. Different letters. And once again, pause the video and see if you can think it through. All right. So this is where permutations start to be useful. Although I think a lot of things like this, it's always best to reason through than to try to figure out whether some formula applies to it. So in this situation, well, if we went in order, we could have 26 different letters for the first one, 26 different possibilities for the first one. I'm always starting with that one, but there's nothing special about the one on the left. We could say that the one on the right, there's 26 possibilities. Well, for each of those possibilities, for each of those 26 possibilities, there might be 25 possibilities for what we put in the middle one, if we say we're going to figure out the middle one next. And then for each of these 25 times 26 possibilities for where we figured out 2 of the letters, there's 24 possibilities, because we've already used 2 letters for the last bucket that we haven't filled. And the only reason why I went 26, 25, 24 is to show you there was nothing special about always filling in the leftmost letter or the leftmost chair first. It's just about, well, let's just think in terms of, let's fill out one of the buckets first. Hey, we have the most possibilities for that. Once we use something up, then for each of those possibilities, we'll have one less for the next bucket. And so I could do 24 times 25 times 26, but just so I don't fully confuse you, I'll go back to what I have been doing. 26 possibilities for the leftmost one. For each of those, you would have 25 possibilities for the next one that you're going to try to figure out, because you've already used one letter, and they have to be different. And then for the last bucket, you're going to have 24 possibilities. So this is going to be 26 times 25 times 24, whatever that happens to be. And if we wanted to write it in the notation of permutations, we would say that this is equal to, we're taking 26 things, sorry, not 2p, my brain is malfunctioning. 26, we're figuring out how many permutations are there for putting 26 different things into 3 different spaces. And this is 26 if we just blindly apply the formula, which I never suggest doing. It'd be 26 factorial over 26 minus 3 factorial, which would be 26 factorial over 23 factorial, which is going to be exactly this right over here, because the 23 times 22 times 21 all the way down to 1 is going to cancel with the 23 factorial. And so the whole point of this video, there's 2 points, is one, as soon as someone says, oh, how many different letters could you form or something like that, you just don't blindly do permutations or combinations. You think about, well, what is being asked in the question here? I really just had to take 26 times 26 times 26. The other thing I want to point out, and I know I keep pointing it out, and it's probably getting tiring to you, is even when permutations are applicable, in my brain at least, it's always more valuable to just try to reason through the problem, as opposed to just saying, oh, there's this formula that I remember from weeks or years ago in my life that had n factorial and k factorial, and I have to memorize it and have to look it up. Always much more useful to just reason it through.